Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about how the wheel and axle and the lever are used in pyramid building, and I have HelperBot here, who knows a lot about these two simple machines, to help out. Let's recall the 6 simple machines: the lever, the pulley, the screw, the wheel and axle, the wedge, and the inclined plane. These simple machines give us a mechanical advantage, which means we can use less force by increasing the distance over which the force is applied. A mechanical advantage means a task is made mechanically easier for us. Today, we're going to be focusing on the wheel and axle, as well as the lever. Say we wanted to build a pyramid, and we have all these large stones that were each 10 tons. That's really heavy. Too heavy to move on your own. It would crush me or HB. However, we can use the wheel and axle and the lever in order to make moving these stones to our pyramid site much easier. First, let's talk about the lever. A lever can look like this, or this, or this. It's typically described as a bar that pivots on a fixed point and can be used to lift an object by applying force to one end. This fixed point is called the fulcrum. Take a look at this diagram. This point here is the fulcrum. When you apply force to this end, it raises the object on the other end, which is applying resistance to the lever. There are 2 other types of levers as well. A bottle opener is one of these types, where the fulcrum is on one end of the bar, and the resistance is between the fulcrum and force instead. A broom is the other type, where the fulcrum is on one end, and the force is in between the resistance and fulcrum instead. Levers allow an object to be lifted by only exerting a small amount of downwards force, which gives us a mechanical advantage. Modern engineers use re-engineered versions of levers today. For example, hydraulic cylinders on dump trucks or lifts work like levers to raise heavy loads. Secondly, we have the wheel and axle. The axle acts like a pivot point, similar to a fulcrum, while the wheel rotates around it. The force is applied around the outside of the wheel where it touches the ground. The wheel and axle are quite common in today's day and still very useful. We see it on cars, wheelbarrows, scooters, suitcases, and more. Even though people didn't have methods of transport like we do now, they did have the simple machine of a wheel and axle. Over time, engineers re-engineered basic logs into circular wheels, then into complex transportation systems like unicycles, wagons, and modern vehicles. Back in the pyramid building days, Egyptian engineers used logs of wood in order to transport huge pyramid blocks. Take a look at this visual. The logs were placed underneath the stones, and people pulled on the rock with ropes to move it forwards, using the logs as simple rotating axles. Every time they'd move past one of the logs, they'd pick it up and move it back around to the front so they could keep going. This method of transportation can be seen as a very simple version of the wheel and axle, and is very useful to us in moving our own stones to our pyramid site. It's also believed that ancient engineers used levers a lot in order to lift large stones into place once they moved the stones to the pyramid site. If we were to transport stones today, we would probably use a dump truck or something similar. The dump truck uses both the lever and the wheel and axle. The lever is used in the form of hydraulic cylinders to lift and lower the back of the truck so stones could be moved. Meanwhile, the wheel and axle allows the truck to easily move around. We, as engineers, have taken our simple machines and combined them with many other simple machines in order to make a more complex and mechanically advantageous one. Speaking of engineers, it's important to keep in mind the engineering design process when thinking about all of this. Many engineers go through this process when inventing new things, like the dump truck, for example. Engineers need to ask, research, imagine, plan, create, test, then improve. It's important to know what your problem is. Then, you need to research your problem to have all the information you need. After that, it's time to start imagining how you're going to solve the problem. Once you have an idea, you plan it out, then you actually make it. Testing comes afterwards to make sure your solution actually works. After you test and see the results, it's time to do the process all over again in order to improve the solution. Multiple iterations of a solution allow you to reach the best possible solution for your problem. Even Egyptian engineers likely use this process, or something similar, when figuring out how to build their pyramids. Now that you know about the lever and the wheel and axle, are there any examples of these simple machines that you can think of in your day-to-day life? For me, I can think of a seesaw or a crowbar for types of levers. For the wheel and axle, I can think of a unicycle or a skateboard. These simple machines are quite powerful, yet very common. They can be used to build pyramids, like the Egyptians did, or you can use them to eat your food and get to school. The possibilities are endless. Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the Teach Engineering website. Then, check your knowledge of wheels and axles and levers by building and racing trucks and wheeling it in.